Okay, so here's the problem. Salmon jump waterfalls to reach their breeding grounds. Starting ground stream, 1.99 meters away from a waterfall that's that high. What speed must they leave at this angle to continue upstream, right? So first, again, before we do anything, let's draw a picture. So here's the waterfall. And the salmon are jumping kind of like this, maybe, until they get to right there. So notice it doesn't say that they reach the waterfall at the peak of their jump, right? It just says that they're going to jump. So in this case, I can't use my typical problem-solving strategies where I just solve for the peak of the projectile, right? Because that doesn't work in this case. So this is delta y. This is delta x. And then I have some initial speed here that's at an angle. So I'll call that v naught, and this is theta. Right? And I'm going to solve, I want to solve for v naught, right? Okay, so the first thing I need to do is I need to break v naught into x and y components using my components, using trigonometry, right? So I know that v naught looks like this at some angle, right? I need to solve for these two components, right? And so, because here's my angle, this side is adjacent, right? This is going to be v naught cosine theta, and this one is opposite, so this is going to be v naught sine theta. Those are my two components. So this is my velocity in the y, and this is my velocity in the x. Okay, got to do that first. So second thing I need to do, I need to figure out the time, right? Time is what links all projectile problems, the x and the y dimensions. So 2, I'm going to find delta t, right? So in this case, I can't use my free fall thing, square root of 2y over g. That only works for this, right? That's not going to work. So in this case, what I need to do is do time in terms of delta x, because I know how far away this is, and I know it's not accelerating this way. It's probably going to be easiest for me to get the time from this distance. So velocity in the x direction is your delta x over delta t, right? There's no acceleration. That's the only equation that applies in the x dimension. Okay, so I'm going to rewrite this to get delta t as delta t equals my delta x over my velocity in the x direction, right? And I already said my velocity in the x direction is v naught cosine theta. So delta t is equal to delta x over v naught cosine theta. Okay, so there's delta t. If I could figure out what delta t is, I know delta x, I could solve for v naught, right? But that's not going to be this easy. So now what I'm going to do is write my y equation. I'm going to plug in what I know to my y equation. So my basic y equation is delta y equals v naught delta t plus, minus 1/2 g delta t squared. Minus because this is a parabola where it's changing direction, right? Okay, so I know my y velocity. This is v naught in the y. I know that's this number. And I know delta t is this. So what I'm going to do, that delta t and that delta t, I'm going to plug this in there, and I'm going to get this big giant equation. So I'm going to say delta y equals, y velocity is this one. That's going to come down here. So that's going to be v naught sine theta times delta t, which is delta x over v naught cosine theta, minus 1/2 gt squared. So that's g times t squared. That's delta x over v naught cosine theta squared over 2, 1/2 gt squared. Okay, so now let's algebra this sum. So delta y is v naught sine theta times delta x over v naught cosine theta, right? I'm just multiplying this with this, so it multiplies by the numerator and the denominator stays underneath, minus g delta x squared over 2 v naught squared cosine squared theta. That squared distributes into everything, right? Okay, so I have this now. And so let's simplify, right? So here the v naughts cancel out because they're both numerator denominator. Sine over cosine is tangent. So this is going to be equal to tangent theta times delta x minus, I don't think I can do much to simplify there. So minus g delta x squared over 2 v naught squared cosine squared theta. That equals delta y. All right. So now I just got to simplify and solve for v naught. See how I only have v naught right there? So all I got to do is simplify this for v naught. So I'm going to add this to the other side. So delta y plus tan theta delta x equals negative g delta x squared over 2 v naught squared cosine squared theta, right? And now I'm going to take these two and I'm going to switch them because I want to solve for v naught, right? I want to get that in the numerator. So I'm going to do algebra and switch those two things. So 2 v naught squared cosine squared theta equals negative g delta x squared over delta y plus tan theta delta x. All right. Oh, so now I'm basically done. Now I just got to move these two things to the other side, right? So I'm going to have to divide by these two things. So, oh, I messed up my sign here somewhere because I added this over. This should be subtracted. It should be minus. All right, because I had to subtract over here. Okay, so now let's I'm going to come over here. I'm going to leave v naught squared, and I'm going to divide this over, and I'm going to divide that over. So v naught squared equals negative g delta x squared over 2 cosine squared theta times delta y minus tan theta delta x. And that's my equation. This will give me v naught squared, and then at the end I could just take the square root of whatever I get here to solve for v naught, right? So just don't forget to take that square root. So when you're doing this in your calculator, it would be helpful to do this in pieces. So in your calculator, do this first. Take the tangent of the angle times delta x, and then do delta y minus that, right? Get a number. Do 2 cosine squared of your angle, and remember that cosine squared theta is the same thing as cosine theta. You get your number, and then you square it, right? So do this number, and then do this number, and then you can do that times that, and do this divided by the product of those two. If you do it piece by piece in your calculator, and then at the end you take your square root, you should be able to get it. But it's not a complicated problem to get to the point where you want to solve, right? It's just using this equation. The complicated part is that I had to combine two equations and do a bunch of algebra to solve an equation I already knew.